Dear students, we are going to discuss about electrostatic potential energy of a dipole in a uniform electric field. So, potential energy of a dipole in a uniform electric field. Okay, so like see this diagram. See this diagram. A dipole AB placed in a uniform electric field. The dipole moment of the dipole is P. You know very well, the dipole placed or kept in uniform electric field, it experiences a torque. This torque rotates the dipole to the direction of the dipole along with direction of electric field. This is the work done by the torque. Then you know very well, the work done stored as a electrostatic potential energy in a particular system. Yeah, see that. You know very well, in previous year from 5th lesson, for translational motion, work done is equal to force into displacement. For small displacement, work is equal to force into ds. Same as for rotational motion, work done is equal to tau into theta. So for small angular displacement, W is equal to tau d theta. Here also we rotate the dipole particular angle. So this is rotational motion. So the work done is an equal and opposite to the external torque must be applied along the or on the dipole. For the dipole rotate from initial angle theta dash to particular angle theta at constant angular velocity. Now the work done is converted the potential energy in the system of dipole. So we do the work, the dipole is rotated at a particular angle by the torque. This is, so we write mathematically, that is, you know, already we discussed. So that is W is equal to, for rotational motion, W is equal to tau theta. For smaller angular displacement, W is equal to tau d theta. So here also we substitute. So we find, so that d theta is the for small angle. So we find the total electrostatic field. So we using integration, W is equal to from initial angle theta dash to theta. Tau external vector, that means tau external vector d theta. You know well in previous classes from this year. So tau, that means see there, tau vector is equal to P vector cross E vector. That means A vector cross B vector is equal to AB sin n cap. That means tau vector is equal to P vector cross E vector. So tau is equal to PE sin theta n cap. Same as we substitute. So the tau external is equal to P vector cross E vector d theta. So P cross E, so that is PE sin theta into d theta. So P constant, dipole moment, E uniform electric field constant. So taking out, then we integrate sin theta. So we get W is equal to PE sin theta, integrate, we get minus cos theta. So the limit from theta dash to theta, then we substitute the limits in this term. So W is equal to PE minus cos theta. That means, so minus cos theta dash. So we get minus into minus plus. So W is equal to PE minus cos theta plus cos theta dash. So that means W is equal to minus PE cos theta plus PE cos theta dash. This work done is equal to the potential energy difference between the position of, that means angular position of theta and theta dash. This work done is equal to the energy potential difference between the two angular position theta and theta dash. Suppose see here, suppose this dipole initially placed perpendicular to this electric field. We taken as this is the reference point. So this dipole perpendicular to the electric field. At the time the theta dash, initially theta dash is equal to 90 degree. Theta dash is equal to now 90 degree. See that. So here if theta dash is equal to 90 degree, that means the initial angle, that is the reference point. Then you know cos 90 0. So you put the value in equation 1. So cos theta dash, that means 0. So del u is equal to minus p cos theta plus p 0, 0 into p 0. So finally we get only u of theta, that is del u is equal to minus p cos theta. This is therefore u is equal to minus p cos theta. This potential energy stored in the system of dipoles, very important in uniform electric field. That means this potential energy stored, that means this is the total. So this total electrostatic potential energy stored in the system of electric dipole when kept in uniform electric field. In vector form you write this equation in vector form, u is equal to p vector dot e vector. So see the equation p vector dot e vector, that means the electrostatic potential energy represents by dot product. See there. So the tau, the torsional, this is the torsional force or torque by or torque due to or torque of the dipole. Torque of the dipole is represent cross product p vector cross e vector. So tau vector is equal to p vector cross e vector. The electrostatic potential energy u is equal to p vector dot e vector. So we clarify, and also from this equation the electrostatic potential energy depends the dipole moment p and E, that is the uniform electric field E, and moreover the orientation of the theta of the dipole, that means the orientation of the theta of the dipole with the external electric field. So how can we judge the electrostatic potential energy maximum or minimum? Comes again this side. See this chart, this is the diagram. Suppose the electrostatic potential energy is maximum. The electrostatic potential energy is maximum when the dipole align the anti-parallel to the electric field. That's mean, so initially it is placed perpendicular. Suppose this is opposite to the electric field. This is the anti-parallel. So this is now at the time the theta is equal to 180 degree. You know cos 180 minus 1. So substitute this equation minus P cos 180 degrees. So minus 1 minus into minus plus u is equal to PE. That is a positive value. Then only we say the maximum. Then when it is minimum, so suppose the electrostatic potential energy of the system of dipole is minimum when the dipole align parallel to the electric field. That means initially perpendicular. So it is move right side. That is it is placed in the direction of the electric field. So now there is no angle between the electric field and dipole. That is theta is equal to 0 degree. So cos 0 1. So u is equal to minus p cos theta. You substitute cos 0 1. So minus into plus minus. So P, this is a negative value, so it is the minimum. So the electrostatic potential energy is maximum the dipole align anti-parallel to electric field. The electrostatic potential energy of the system of dipole is minimum when the dipole parallel to the electric field. This is a very important one mark. So we learn from this topic. We conclude the electrostatic potential energy represent in dot product, the torsional force represent in vector product. That's it. Thank you.